So hi, this is Shomik Vishwas. This is a continuation of my first lecture. So here I am talking about the combinations of the different elements of the circuit. In the past lecture I have covered about the resistance. In this particular video I have covered mainly two basic type of the other elements like capacitance and the inductance. So before going to that inductance and capacitance, I would like to tell about something on that series and parallel combination. So if you are having one series circuit, so what happened actually? So suppose some resistance are there, say this is some resistance, so this is R1, this is R2 like this, but the current flow is same. But what is the difference? That is a voltage drop. Here it is V1, it is V2 like this. So in the series circuit the current is same through all the elements, but the voltage drop is different. But in the case of parallel circuit, what happened, that in this you can see some resistance are like this. So here if it is I1, it should be I2, but the voltage here V is fixed for, say if it is R1, if it is R2. So for R1 the voltage is fixed as V, for R2 the voltage is fixed as V, but the current here is I1, the current here is I2. So basically when you are taking some capacitance, actually capacitance, so that important formula is Q equals to Vc. So we can write that dq of dt equals to C or dv of dt. So the dq of dt means what? Rate of change of Q means the charges. So rate of change of charges during that time is what? That is the current flow. It's I equals to C into dv dt. So here okay, so this is now here if we consider this particular line as this is C, this is C, this is C, having different value, that is C1, C2, C3 in this way. So obviously the final one is what? Here the drop is V1, here the drop is V2, here the drop is V3. So you can write as that final capacitance, you can write if that V equals to V1 plus V2 plus V3. As you know that here from you can integrate, you can getting as IT dt integration of 0 to t into 1 by C equals to V. Okay, so finally I can write that 1 by C total integration of IT dt equals to 1 by C1 integration of IT dt plus 1 by C2 in this way. So finally it comes as 1 by Ct equals to 1 by C1 plus 1 by C2 plus 1 by C3 for n times. For this case of what is the series combinations. Now if you are taking some parallel combination, so what happened, that obviously the reverse case will come. So Ct equals to C1 plus C2 plus C3. Now you can ask me why, because in that parallel case the voltage is same, so therefore this V is same, but what is different, that is I is different. So that changing is happened, that here I is different. So in that parallel circuit you know that I equals to I1 plus I2 plus I3. So henceforth you can write that Ct dv dt, because same voltage, equals to C1 dv dt plus C2 dv dt, etc. So therefore Ct equals to C1 plus C2 plus C3. Okay, now if we am taking the same thing for inductance, so here what is the important formula? That phi equals to Li. Here phi is a flux linkage and I equals to current and L equals to inductance. Okay, so finally d phi dt equals to L of di dt. As you know, the d phi dt is the change of flux, so it must be equals to induced voltage, that is equals to VL. So finally what can I write? That here that I can write as 1 by L VL T dt integration of I. So where I is different as the summation of written as I1 plus I2 plus I3, so 1 by L total equals to 1 by L1 plus 1 by L2 plus 1 by L3. So this is a what? Parallel combination. And for series, LT equals to L1 plus L2 plus L3. So what is the important decision we have made from here? That the behavior of L and R is same in series parallel, but C is reversed. So what is the parallel type? It is applicable in C series. What is series type? It is applicable in C parallel. Fine. So one thing is very interesting, all should know this. We know that for capacitance, what I can write, that I equals to C into dV dt. Now if it is V equals to V dC, so that dV dt equals to 0. So I equals to 0. So capacitor block DC up to a fixed level, else pass. But if it is AC, so it can easily pass through that capacitance. Now same thing applied will be that V equals to L di dt. Now if it is inductor, so obviously that di dt is absent in DC, so obviously V equals to 0. So act as a short circuit at DC level, but open circuit at AC level. Okay.